In this video, we're going to talk about how to convert an octal number into a binary number. So let's say if we have 56 in the base 8 system, that is in the octal system, how can we convert that to a number in the binary system, that is in the base 2 system? So what you want to do first is separate the 5 and the 6. Now you want to break it down to these numbers, 4, 2, and 1 for each one. 2 to the 0 power is 1, 2 to the first power is 2, 2 squared is 4. Now, to convert 5 into a binary number, you need to realize that 5 is the sum of 4 and 1. So because we used 4 and 1, we're going to replace that with a 1. We didn't use 2, so we're going to replace that with a 0. Now, 6 is the sum of 4 and 2. Since we used the 4 and 2, we're going to replace that with a 1. We didn't use the 1, so let's replace that with a 0. So 56 in the octal system is equal to 1, 0, 1, 1, 1, 0 in the binary system. And so this is the final answer for this problem. And that's how you can convert a number in the octal system to a number in the binary system. Now let's try another problem. So let's convert 35 from the octal system to a number in the binary system. If you want to pause the video, feel free to do so and try this problem. So let's begin by separating the 3 and the 5. And let's write the numbers 4, 2, 1 for each. Now 3 is the sum of 2 and 1. So we're going to replace 2 and 1 with a 1, and we didn't use the 4, so let's replace that with a 0. Now 5 is the sum of 4 and 1. So let's replace 4 and 1 with a 1. We didn't use a 2, so let's substitute that with a 0. And that's it. So 35 in the octal system, we can write it as, now here's the question, should we write it as 0, 1, 1, 1, 0, 1? Now, if you have a 0 in the front, you need to get rid of that 0. So therefore, we only need to use these 5 numbers. So the answer is going to be 1, 1, 1, 0, 1. So watch out for that. So this is the answer. Now, if you want to check your work, here's what you can do. Let's convert the octal number into a decimal number, a number in the base 10 system. To do that, you need to multiply the 5 by 8 to the 0 and the 3 by 8 to the 1. So it becomes 3 times 8 to the first power plus 5 times 8 to the 0 power. 3 times 8 is 24. 8 to the 0 power is 1. So that's 5 times 1, which is 5. And so the sum is 29. Now, to convert the binary number into a decimal value, here's what you need to do. So the first number we need to multiply by 2 to the 0, the second by 2 to the first, and then 2 squared, 2 to the third, and 2 to the fourth. So we have 2 to the fourth plus 2 to the third plus 2 squared, and then 0 times 2 to the first power is 0, and then we have 1 times 2 to the 0. 2 to the fourth is 16, 2 to the third is 8, 2 squared is 4, anything raised to the 0 power is 1. Now 16 plus 8, that's 24, 24 plus 4 is 28, 28 plus 1 is 29. So we get the same answer. Because these two are the same, we know for a certainty that these two must be equivalent to each other. And so that's how you can check your work. For the sake of practice, let's do one more example. 643 in the octal system. Let's convert it to a number in a binary system. So the first thing we should do is separate each digit. Now to get 6, we need to add up 4 and 2. And so let's replace those numbers with a 1, and then the other one that we didn't use, replace it with a 0. To get 4, all we need to use is 4. So this is going to be 1, and then we didn't use the other numbers, so 0 for the 2 and 0 for the 1. Now to get 3, we need to add up 2 and 1. So that's going to be 0, 1, 1. And thus, we could see our answer right here. So 643 in the octal system is 110100011. And so this is the final answer. So now you know how to convert a number from the octal system to the binary system.